Hello everyone, today in this tutorial we are going to learn about how to create agent using AWS Strands Agentic Framework, which is an open source agent framework released by AWS in the recent past and the open source community. Then we are going to learn about how to use AWS Bedrock AgentCore Runtime to deploy that agent which was created by AWS Strands Agent Framework. So let's first understand what is this AWS Strands Agent Framework, and then we will run through few examples, and then we will see actual example where we are going to use the tools with the agent and then deploy it into the AWS Bedrock AgentCore Runtime. So let's get started. So as you see in this diagram, I have shown in this block, this box, that this is an agent, and this agent is nothing but a similar kind of agent like we used to create using LangGraph, LangChain, etc., or Creo AI. Those who are familiar with this kind of frameworks. So this on the same lines it is, but it has major capabilities because it allows you to interact with LLM outside AWS, as well as it allows you to go through AWS Bedrock. Plus there are plenty of benefits of using this particular framework. So this agent is, again, user gives a chat request, agent receives it, and then it actually sends it to the LLM respond back, and basis on the response it calls the tools, and then ultimately sends the response to the LLM again, and then finally prepare the response back to the user. Okay, this is the very basic thing I've talked about. Although it has an agent loop concept where it goes into a loop of tool interaction and LLM until it prepares the final response to the end user. Okay, now let's talk about how to set up. What is the minimum setup you require to write a code for this agent using this AWS Strands Agent Framework? Let me show you first what is this Agent Strand Framework. It is open source. It is present on GitHub public repository. It has Python SDK as well as TypeScript SDK. You can use any of this language, but we are going to use Python in this particular video. So we are first going to see what is the minimum setup you needed, and then how to create a very simple agent. So in my VS Code, I've already created a few example over here, which is I published into the Learn for Tarakki GitHub repo, which is a public repo. Let me show you. I will provide the link of this particular repo into the video description section. You can freely go there and try this example. README file is also present. You can follow the README file, and we are also gonna cover this in this video. You can also get this diagram into the repository itself. So you are very familiar with this, and you can easily do a hands-on using this repository. Okay, using this particular project. So let's go back to the VS Code. So what is the setup here? You must be familiar with UV. Those who are not, you can watch out the UV tutorial. I can put the link description on top, so you can watch out the UV tutorial to create the simple Python project using UV. So you don't have to use pip, etc. if you are having UV in your system. So currently I'm sitting on Ubuntu OS, and I have VS Code with me, and then I have created a simple project using UV init command. First I run the UV init command, then I rename the hello.py, which it created automatically, to these particular files 01, 02, 03, 04. 4 examples I have in this project. Okay, then for the Strands framework to work, I've used UV add command to add the dependencies. What dependencies I have added? These are the dependencies. Okay, the very first dependency for creating a simple example 01 is nothing but this Strands agents. Okay, you just have to install the Strand agents. If you follow this tutorial, okay, Python 1, getting started Python 1, you just have to install this Strands agents. You don't have to use the pip install command. If you are using UV, you just have to type in UV add, then Strands agents. That's it. It will put an entry over here and install that into the .venv directory in this lib folder. Okay, so it will get created automatically. Don't worry. Okay, and after that you can simply jump here 01 and simply import the agent from the Strands and create an object of this agent. Simply call it. Okay, and then this agent is created. Now those who are thinking that now what about LLM, etc., right? So what Strands framework does internally, it actually points to AWS Bedrock, this particular model ID, US Anthropic Claude Sonnet 4. Okay, so let me show you the code of the Strands framework. This particular code, SDK Python SRC Strands models bedrock.py. In this particular line, it is showing default Bedrock model ID. Okay, so if you do not provide anything in the constructor, by default it is AWS Bedrock Cloud Sonnet 4. So I am printing here the default model here as well, and then you can run this command code. So to run this code, you can simply type in uv run 01 tab, hit enter. Okay, this program will run and show you the default model and also the answer of this particular question. Okay, so this is a very basic setup, and this is what the outcome looks like. Now you talk about what is the customization you can do. If you want to change the model that this particular agent is using internally, you can simply change this model ID over here. Simply type in, for example, model equal to, in double quote, you can pass in the ID, a different ID. Instead of this particular string, like you can pass in like this as well, it will still work. Okay, so you can change this particular ID string and to point it to a latest LLM model as well. Okay, for the sake of time, I'm not showing this example, but this IDs where you can find, you can go to AWS Bedrock. What are the possible IDs, right? This is the AWS Bedrock screen. You log in into the AWS console and find the AWS ID over here. Here, type in AWS Bedrock overview. Over here, you can go to the agent. Let me just try to find out Inference profiles. Okay, Inference profiles are the profiles that AWS Bedrock by default created for you. You can create your own inference profile by going to the application. So at the application level, inference profile you can create. It is just a profile to access a model by the application. Okay, so system defined one is created by AWS. You can simply go there and find that ID string and use it. For example, Cloud Opus 4.5. You can click on this, and then you can simply copy the ID string, okay, model ID string from here and use it. This one, okay, copy it and use it. Previously, few months back, we used to basically, for accessing the model, we used to request that we need to access the model, then the AWS provide the permission, etc. They actually retired this particular approach. They have created the model reference approach, like this particular inference approach in AWS. By default, inference profiles are created by the AWS, which is system-wide inference profile. System-wide means the entire application, like set of applications, all of them can access a model. If you have to do the application level access, you can create your own inference profile. We will talk about this into another video. Okay. Now let's go back to VS Code. Now this is how the model can be altered. The second example is how to explicitly provide a different model of AWS Bedrock. Suppose, and also control the parameter. You can simply import the Bedrock model from AWS Strands.models import Bedrock model. And in this Bedrock model constructor, you can pass in a different model ID, set the temperature, lesser the temperature, more narrow is the results basically, right? More the temperature, more wider and creative results maybe, okay? And the region name. And after that, you just have to invoke it, pass in the model object. As I talked, it can be a string or it can be an object, okay? And then finally gets the response. This is how you can simply use the custom Bedrock model. The third example is, you can, if you don't want to use the AWS Bedrock, that's fine, because AWS Strands work outside the box like LangGraph, LangChain. It is created by AWS, open source by AWS. It doesn't mean that you have to stick to AWS altogether to make use of it. It's very mature framework. You can simply use it for your own, pointing to a different LLM, or you can do whatever you want, okay? Like instead of using the AWS, but it is recommended to use AWS because it is a very good set of features tied with it, okay? Now, how to use the Cloud API direct? This is example. So we here in this case, we are simply importing the Anthropic model. I've used the python.env in the UV directory, you can uv add python.env, okay, to actually load the .env file which is present here. I'm not opening this file because it contains my API key. So you can simply configure the Anthropic API key and use this particular model into this example. Like API key you can pass in over here and then it will work simply. Okay. In this example, it is giving me error. So I've done some exception handling over here. And because I don't have, like, you can say credits, so that's why I got an error. So I put in the exception handling over here. You can obviously go through this example. Now let's talk about the fourth example, which will give you a little more depth of the agent, like the way you might have seen the earlier video of our channel that talks about the tool calling, etc. So it is not about single discussion with the agent talk to LLM and prepare you the result. The real world example is that agent talks to different tools basis on the requirement and then finally prepare the response for the end user. Now Strands provides the built-in tools as well. You can install the Strands tools. For installing the Strands tool, you need to enter uv add Strands agents tools for this example to run. Okay, and what in this example we did, that we first created the tool. How to create a tool? @tool annotation and then normal function, Python function. While writing the Python function, the most important thing is this particular function level comments. Okay, if this function level comments has a problem, then obviously it's difficult for LLM to decide which tool to call, because basis on this particular function level documentation, it able to identify whether to call this particular tool or not. So you cannot skip this particular part. It needs to be defined correctly as per the context that LLM can understand it. Okay, so what this example is, in this example, let me talk about it. I am providing the input. Okay, this is my expenses of this week on different category of items. Now I have added tools, different functions. One is to add the expense into the system. Then second is to get the summary of this spending. Third is to get the largest expense. So I provided this 3 function as a tool into this agent. Okay, then I asked this agent, please add all of this, then show me a spending summary and tell me the largest single expense. Okay, so what it does, it automatically makes a call to LLM. LLM will parse this, understand this particular question, and then decide which tool to call. So since first is add all of this, it will understand, okay, this is an expense, I need to call the add expense. Then agent will call, agent gets the response from LLM, then call the add expense method with the right set of argument. Okay, then it adds this expenses into the expenses list. Then it invokes the spending summary tool. Then it invokes the largest expense tool, and finally sends the overall response to the LLM once again, and then final response back to the user. Okay, so I can run this example quickly to show you how it works. uv run 04, hit enter. Okay, you can see this example running. So the expenses are getting added by the tool call, add expense tool call, and then the summary is get spending summary tool is getting invoked, and finally the get largest expense tool is getting invoked, and ultimately the response arrives to the end user, which is me. Okay, so this is how the continuous loop is happening behind the scene in this AWS Strands code and with the LLM, and you will get the response. This is one such example. Obviously in multi-agent scenario, agent talk to another agent, there is an orchestrated agent, and then talk to another agent talk to different tools, and finally prepare the response for you. Okay, so this is the final response that arrives to me. So this is how the Strands Agent Framework is quite easy to configure, set up, and you can obviously create many things with this agent framework. We will understand more about it in a subsequent video. We will talk about the short-term, long-term memory, because as the conversation is happening between the LLM and the agent, this intermediate conversation needs to be stored somewhere, right? Like we talk to someone, we talk a lot. For example, for half an hour we talk. We have something in our background to discuss about the new things. Like we know, like, okay, these are the conversation already happened. We have some idea on it on the back of our mind, right? So that is nothing but short-term memory. And long-term memory is like, it's like long-term memory, you can think of it like a hard disk, and short-term memory you can think of it like a RAM. Okay, so Both of these capabilities provided by AgentCore Runtime by AWS Bedrock. So we'll talk about it. So, and also there is a concept of session, state management, etc. We will talk about this in the another video. So this is all about Strands framework. So quickly see the diagram again. So this I have covered. Agent talks to LLM, gets talk to tools and make use of the memory. Currently we have not configured the memory. We have configured at the time of AWS AgentCore Runtime. I will show you. And then this state is nothing but when we have multi-agent scenario, then state is made use by the agents in order to transfer the information between across the agents. Okay, it is not being passed to the LLM, means the state information is not passed directly to LLM or automatically to LLM. It is made use by the agent. Okay, now let's talk about the agent AWS AgentCore Bedrock Runtime. Okay, now you created the project in the local. Now what happened? You have to expose this project, right? Like for example, you created the project, but in the real scenario, you have to deploy it into the production environment and expose it as an endpoint, right? You normally what you do, you have a front end, you have a back end, you expose the back end as an endpoint and then integrate with the front end, correct? And the back end also have multiple backend services that talk to each other. So ultimately your agent needs to be hosted somewhere, and then that agent has to expose the endpoint, and then only they can talk to each other. For that, AgentCore is one of the solution. Otherwise, the first solution the people tend to do when the AgentCore was not present, they tend to create a fast API server, expose the endpoint of this agent, and deploy that fast API server into ECS or EKS or EC2, etc. in the form of Docker container. But AgentCore actually simplified this whole thing. It provides the additional capabilities, plus it automatically wraps the code into a Docker container and deploy it into the AgentCore runtime. So let's see how it does. So for that, what we are showing here, we are going to deploy this particular code into the AgentCore runtime. And how? For that, this particular 04 example, I'm going to wrap it and expose this particular code 04 expense tracker 1 as an endpoint. Okay, how? So for that, I have written a code main.py. This main.py, think of it like a server endpoint or server logic. Those who are familiar with Node.js or Fast API, those people create a server.py file, etc. Right? So similar, you can think about that only. Okay, internally it makes use of Starlet only, which is also the backbone of Fast API. So this also use the same Starlet framework. Okay, so here what we are doing, simply we are importing this expense tracker agent. Since we started this particular file with name 04 like a digit, so I need to use the import lib particularly to import this particular as a library. Otherwise import might have worked. Okay, now I created the object of Bedrock AgentCore app. Now before that, you need to install some dependencies for Bedrock AgentCore runtime to work. For that, you need to use the uv add command again with this Bedrock AgentCore, uv add Bedrock AgentCore, uv add Bedrock AgentCore starter toolkit. The starter toolkit is nothing but CLIs given by AWS AgentCore. So with this CLI or with this commands, you can simply deploy it directly into the AWS core runtime. This particular code which is present in your local can directly be gone over there. For that, the minimum requirement is you need to have an AWS account, you need to have an IAM role of AWS Bedrock full access or something like that. And then you need to be able to connect to that AWS using AWS profile. For that, you need to, in the local, you need to configure AWS config, as well as you need to do the AWS configure using the IAM role, access key ID and secret key. Okay, I've already done this in my system, so you need to follow the same thing. Okay, and then added this Bedrock AgentCore and this particular both the dependencies. After that, you need to write the main.py code. Simple, just have to create the object of it, and at the rate app.entry point is nothing but endpoint entry point, like REST API endpoint entry point. So what is this? It is a post endpoint slash invoke post endpoint. It automatically exposes that endpoint. Normally in Fast API, you create the route, right? And then expose it. Similarly, internally by default, it creates slash invoke post endpoint for you. And that on that endpoint, we can invoke this endpoint with a prompt. And then this endpoint will internally make call to the agent talk to LLM, etc. and respond back to the end user, okay, who is calling this API. And after that, app.run. So this is the simplest code that you need to write to deploy it into the agent core. Okay. Now what happened? What is the next step you need to do? I have already written it into the README file. Let me open the README file in preview mode so that it is easier to read. What is the first command you need to type in? The CLI command. Okay. First, I have talked about this, install the dependencies. Then the second command you need to fire up is UV run AgentCore configure command. Okay. And -- name, the name of the agent, and entry point. Main.py is the entry point. Okay. After this command, it asks few questions from you. Okay. What are the questions? Dependency file. Where is the dependency file? py project.toml. It automatically detect, ask you to confirm. And then deployment type, whether it is a direct code deployment, no Docker or container. Okay. Basically, direct code can be deployed without using the container. This is also in you can say support by AWS AgentCore Runtime, or create a container. Okay, I have selected this option, container. Okay, then execution role, it will automatically create a role for you, or you can also control how to create the role. Okay, auto create. Then I have provided the ECR repository URI, and then authorization. I've used a default IAM authorization, and request header allow list. I have skipped it because it asks us to actually forward the headers. Okay, whatever the actual header coming from the user request. Memory setup, I have set up the short-term memory. I have simply entered yes, and long-term memory I entered no. Okay, you can obviously try this option. And then the second command after that is, now after hitting this yes, what it does internally, it automatically creates the short-term memory into the AgentCore runtime. Let me show you quickly. In the AgentCore runtime over here, AgentCore runtime, right? In the AgentCore runtime, it created the short-term memory. This is the short-term memory, version 1. Sorry, this is the runtime memory. If you go into the memory, so this is the short-term memory created from the local machine to this environment automatically. Okay, after running that command. Okay. Before I talk about more about AgentCore runtime, let's simply talk about it. The capability of AgentCore runtime, I did not talk about it. Sorry. So basically, it has multiple capability: short-term, long-term memory. We are discussing this. Built-in tools, code interpreter, browser. There are a couple of tools which is built in. You can also create your own tool and host it within the AgentCore runtime. There is a concept of gateway which acts as an orchestrator layer between different agents, and also it provides you rate limiting, etc. So it is an advanced gateway specially designed for agents. Okay, and also authorization, security, rate limiting, all of that support is present within this gateway. We'll talk about it in another video. Identity and access management, policy control, like which agent can call which tool, etc. and runtime tools, etc. And it also has a built-in observability capability. And plus, the most important thing is evaluation, like grounding the truth. We have the concept of responsible AI, etc. So those will be covered soon. Okay. Now let's go back to this command. After that, memory gets created. What it internally does, this configuration, it creates this particular folder .bedrock AgentCore, creates a Docker file for you. You don't have to create your own Docker file. It creates it for you. Okay. And then ultimately what we have to do, we have to type in this command. Simply second command, sorry, in the preview mode, this UV run AgentCore deploy. Now what is this particular flag? Some people confused by this flag. If you have the Docker desktop running into your local system, I have the Rancher desktop installed into my system, otherwise Docker desktop running. What it does, it simply creates a Docker container and deploy it into the, simply creates a Docker container and then simply deploy it within your Docker desktop environment. Okay, it does not actually push it into the ECR, etc. Okay, if you want to test your endpoint within your local environment itself, then you type in -- local. Okay, and that's it. It simply exposes the localhost endpoint in your local machine, and then you can simply test it. Okay, by using this command UV run AgentCore invoke command and put in the actual prompt. Okay, and you will get the response. But if you want to deploy it into the AgentCore runtime, you don't have to use the local flag. UV run AgentCore deploy. What it does internally, let's understand. When we run this command, what are the steps is happening behind the scene? These are the steps. This is the code which is sitting in your local machine. When you type in AgentCore deploy command using UV run, make sure you are using UV run because we have installed the dependencies within the UV. So we are not running the command simply by AgentCore deploy. We are running the command using UV run. Okay, let's go back. Now this code is actually pushed into the AWS S3 bucket automatically. Okay, it creates a bucket for you if you don't provide the bucket, and push that zipped file into the AWS S3 bucket, and then it automatically runs the code build to create a Docker image for you and push it into the ECR registry. Okay, and then finally that image is getting run into the AgentCore runtime automatically. So with this command, deploy command, you actually push your latest code into the AgentCore runtime. Okay, so what it does, let me show you. Yeah, this is the code build. You can see here build project over there. First build was failed because there is a permission issue. I've also mentioned into the readme troubleshoot why the permission issue. AWS Bedrock do not have permission to push into the ECR. I provided that policy and then run it again. So it succeeds, and ultimately succeeding, it deploys into the AgentCore runtime. Okay. So if you look into this runtime, you will be able to see this is deployed. Okay. You can test it from here itself, or you can test it with the UV run AgentCore invoke command. Okay. Directly writing it over here. Like for example, if I type this command over here, let me clean this up and paste it over here. This will get executed against the AgentCore runtime. Okay. Just ignore this warning. This is a dependency, internal dependency warning, nothing problematic, and you will get the response. This is the response from the AWS AgentCore runtime. Okay. Now you can simply test it from the AgentCore runtime itself. You have to simply go here, agent sandbox, and type in the same prompt over here and hit run. Like for example, I can simply copy this prompt from here, and I can paste it over here and run. So it run against the deployed agent over here. Okay, and give you the result. Plus it also has the observability capability. You can simply check the traces, logs, metrics, etc. out of the box directly into going into the CloudWatch. Over there you have a GenAI observability. Model invocations, you can check how many invocations of the model happened, and you can keep track of it. You can check invocation count, latency, token counts by model, etc. And then you can go to the Bedrock AgentCore over here. You can also check the capabilities, endpoints, how many endpoints. We have exposed 1. Number of session 2, we have talked to this particular AgentCore 2 times from our local system. There are 2 sessions gets created. And obviously you can talk about the traces. I don't have a X-ray enabled, so there is some issue in earlier, but then I created it. So traces, you can see logs, you can see in the log management, you can see the logs, then you can see the metrics over here. We'll talk more in depth in the upcoming video about it. So this is how you create the agent using AWS Strands framework. You deploy it into the AWS Bedrock AgentCore runtime and test it out. Okay, so this is all about the tutorial of this particular session. So you can see that this is what is happening. User endpoint is invoking, and AgentCore endpoint this agent is exposed as an AgentCore endpoint, and finally the things are working as we are planning, right? So overall, I hope you understand this AWS Strands and Bedrock AgentCore. You able to understand it. If you don't understand it though, please write a comment on the comment section. If you really like it, please subscribe to our channel. I hope that will give me a good boost to create new videos on this topic. I hope you understand this and really like it. Thank you so much for watching this video. Stay tuned, stay connected. Bye.